So this is going to be my third effort at doing this problem. These problems are a little bit tedious at the back end of this video. Each of the problems in the last group of problems between 37 and 51 have three unknowns, x, y's, and z's, and three equations. We're going to solve these by using the elimination method, and we're essentially going to do the elimination method 3 times. Some of the problems will have infinitely many solutions. Some of the problems will have no solutions. The problems we're going to do are just going to have one solution. Just like in the last grouping of problems, if all the variables cancel out, if you're left with a false statement, there's no answer. You would just write inconsistent or no solution. If all the variables dropped out and you're left with a true statement, then you need to write your answer in a fancy form because there's infinitely many solutions. And we're going to skip those and just do the problems that have one solution. That's going to be enough. These are tedious enough. So we're going to stop at problems 42. Beyond problem 42 are either the inconsistent with no solutions or problems with infinitely many solutions. So we're just going to do for these 3 equations and 3 unknowns the problems that have one solutions. So I wrote a skeleton of steps here. Step 1, pick one equation and pair it with the other 2. Sometimes I tell you what I want you to do for step 1. That would be because it makes it easier for me to grade. Our work can look remarkably different if we don't follow the same steps, but we can still get the same answer. So just to make it easier for you to follow and for me to follow when I'm grading, sometimes I tell you what to do. So for my step 1, I'm taking an equation. I'm picking the bottom equation. The bottom equation is x minus y minus 4z equals to 14. And I'm throwing a bunch of 1s. Anytime a variable has a coefficient of an implied 1, I'm going to write down that 1 just to try to minimize my mistakes. I am not very good about being careful, and I often write down numbers wrong. That is a kiss of death for these problems. If you write down one number wrong, bad things happen. And everything after what you write down is not good. So I'm creating 2 groups of equations. One with the bottom equation and the middle equation, and one with the bottom equation and the top equation. When you do these, it doesn't matter which grouping you write first, which grouping you write second. It doesn't matter which equation you have on the top, which equation you have on the bottom. Just pick one of the 3 equations and group it with the other 2. And there's no restrictions in how this is done. Just put them together. So that's my first step. I picked an equation. I picked the bottom equation, paired it with the other 2. Wouldn't have mattered if I wrote it on top or bottom. I just wrote it on top because that was the equation I was picking. Step 2, pick a letter to drop out and then do that dropping. I decided to drop out the y's, and I'm going to use the elimination method to drop out the y's. The reason I picked dropping out the y's is because this part was going to be easy. To drop out the y's from this pairing, though the y's have opposites as their coefficients, I can just add these together without doing any changing. Go 1x plus 1x is 2x. Cancel the y's. Negative 4z plus 2z. These have opposite signs. These will combine to be a minus 2z. 14 plus 0 equals to 14. Done with that half. Move on to the other half and drop out the same y. The y in this top equation, if I multiply that negative 1 by 2, I get exactly that negative 2. That's not quite good enough, but close enough to good enough to cancel. I'm going to make this top y have a positive 2 in front of it, so it will cancel with the y beneath it. To make that happen, I need to multiply through by negative 2 in the top equation. So I'm going to go negative 2 times 1x is negative 2x. Negative 2 times negative 1y is positive 2y. Negative 2 times negative 4z is positive 8z. And negative 2 times positive 14 is negative 28. So just be super slow and careful to make sure you're not writing down a number wrong or doing a multiplication wrong. Any mistake that you make is going to be super hard to find, and it's going to make everything after it wrong. So now I've set these up so I can add these together and drop out the y's. So I'm going to go negative 2x plus positive 3x is positive 1x. Cancel the y's. 8z plus 1z is 9z. And negative 28 plus 15 is negative 13. That's the end of step 2. I picked the y, I dropped it from both pairs. From this first pairing of equations, if at any time all the variables are divisible by the same number, it's permissible to do the division and work with the more simplified form of that equation. And anytime you can get numbers smaller, it's probably a good idea. So rather than using with the equation that the algebra produced, I'm going to use this modified equation for my step 3. So for step 3, I'm going to take the two equations created in this last step, specifically 1x minus 1z equals to 7, and 1x plus 9z equals negative 13. I'm going to stack them on top of each other and solve for both x and z using the elimination method. At this point, I have a lot of flexibility, so our works can start to look remarkably different. I don't like multiplying by negatives, so I'm going to cancel out the z's by multiplying the top by 9. You could cancel out the x's by multiplying either equation by negative 1. So it doesn't matter when you're using the elimination method how you choose, what variable you choose to eliminate. I'm so poor with working with negative signs that I like to multiply by positives when at all possible. I also prefer to only multiply one equation rather than two. The least multiplying by positives and only multiplying by one equation is kind of my goal. Multiplying by negatives, I make mistakes. Multiplying both equations, that doubles up the chances for me to make my mistakes. So did the multiplication. Now I'm going to add these. I go 9x plus 1x is 10x. The z's cancel. 63 plus negative 13 is 50. Got to get an answer here for x, but that's only 1/3 of the answer that I need. I need an answer for x, y, and z. And the algebra here helped me get an answer for x. I'm not worried about these bottom equations just yet. I'm not done with this step. This step 3, I should get answers for 2 of the 3 variables, so I can get an answer for z. And I'm just going to use this top equation to solve for z. So in my efforts to solve for z, I need one of the equations that has the z, and I'm going to use this 1x minus 1z equals to 7 just because of the 1's. I don't like the negative in front of it, to be honest with you. But I'm going to change the x to 5 and get 1 times 5 minus 1z equals to 7. This is going to give me 5 minus 1z equals to 7. I'm going to minus 5 and minus 5. That's going to give me minus 1 times z equals positive 2. And then I'm going to divide by negative 1, divide by negative 1. On the left-hand side, negative 1z divided by negative 1 is just positive z. On the right-hand side, 2 divided by negative 1 is negative 2. So I have an answer for z, I have an answer for x, and I finished step 2. Step 3, or I'm finished step 3. Step 4, take the answers that I just got, x equal to 5 and z equal to negative 2, and plug them into any one of the original equations. So for the final answer, to get the y equal to 1, pick any equation. I'm going to pick this bottom equation because it has so many, I'm going to look at the right equation. I'm going to pick this equation because it has nothing but positives. So in my effort now to solve for y, because I have an answer for x, I have an answer for z, I need to pick any one of the equations. It doesn't matter which one. This one's nice because it doesn't have any negatives. So very specifically, I chose this because the numbers were all positive and I make less mistakes. What am I going to do? I'm going to plug 5 in for x. I'm going to plug in -2 for z. And this is going to give me 5 plus y minus 4 equals to 0, which is going to give me y plus 1 equals to 0, because I could go 5 minus 4 is 1, and then I minus 1 minus 1. This will give me finally y equal to -1, and I wrote my answer as an ordered pair in alphabetical order, the x first, the y second, and the z third. So 5 was the x, -1 was the y, and -2 was the z. If I want to, I could check. So I'll calculator check one row at a time just to show you. So what I need to be able to do is go to the top equation, change the x to 5, make it 3 times, make the top equation 3 times 5, for 5 for the x, plus 2 times -1 for this y, plus -2 for that z. And when I hit equals on this top equation, I should get 15, of course. So, oh my gosh, 3 times 5 minus, oh my gosh, 2 times -1 plus -2 equals. There's 15. I don't have any idea what I entered wrong on the first time. So do it to the top equation and then the middle equation. 5 for x plus -1 for y plus 2 times -2 for z. Should be 0, which it is. And then the bottom equation. 5 for x minus -1 for y minus 4 times -2 for z, and you get 14 equal to 14. So these all can be checked. So that's just one problem. That's 12 minutes. This is why we're trimming these as short as we can. So let's do 39 together just to knock out one of your homeworks. So for 39, I don't have the answer written down. Dangerous as heck. Let me just check real quickly what the answer is. At least I'll try to do some work in my head, which is probably stupid. Have the answer on my computer somewhere, I just don't want to look at it. I think the answer is 1, 2, and 3. 1 for x, 2 for y, 3 for z. This is assuming I didn't make any wretched error. So what were my hints? My hint said take the middle equation, pair it with the other two, drop out the x's. So my middle equation, if I put 1's where the implied 1's are, is -1x plus 1y plus 2z equals to 7. I need to put that with the top equation, which is 2x plus 1y minus 5z equals -11. And then take the middle equation, -1x plus 1y plus 2z equals to 7. Make it with the bottom equation, which is 1x minus 3y plus 1z equals to -2. Absolutely double, triple check here to make sure you haven't written anything down wrong. One wrong coefficient, one wrong sign, everything after it is wrong. Okay, now I'm going to drop out the x's. The reason I make the x's because they're easy to drop out here and not so hard to drop out here. In this pairing, I'm going to drop out the x's by multiplying this equation by 2. I'll go 2 times negative 1x is negative 2x. 2 times positive 1y is positive 2y. 2 times positive 2z is positive 4z. 2 times positive 7 is positive 14. In this grouping, I don't need to change the bottom. I could leave it at 2x plus 1y minus 5z equals negative 11. Add the equations together. The x's cancel here. 2y plus 1y is 3y. And then 4z minus 5z is negative 1z. 14 plus negative 11 is positive 3. Use your calculator here. It's much smarter than doing what I just did, trying to do math in my head. One mistake will doom you, and it's so hard to find. So now for this pair, I can just add them together and drop out the x's, which was my goal. So drop out the x's there. 1y plus negative 3y is negative 2y. 2z plus 1z is positive 3z. 7 plus negative 2 is positive 5. If I've made a mistake, everything I'm about to write now, I'll have to erase and do over. So it's super important to go slow, not make mistakes. Even when I go slow, I make mistakes. So that's the end of step 2. First step, I took the middle equation, paired it with the top and the bottom equation. Then I dropped out the x's using the elimination method. Now I'm going to take each of the equations created in this step and stack them on top of each other. So I'm going to take the 3y minus 1z equals to 3 and stack it on top of minus 2y plus 3z equals to 5. And I should be able to get my answer of y equal to 2 and z equal to 3 from this step. I'm going to solve using the elimination method, and with one multiplication I can drop out the z's. If I just take this equation and multiply it by 3, I'll set the z's up to cancel. So let me do that. I'm going to go 3 times 3y is 9y. 3 times minus 1z is minus 3z. 3 times positive 3 is 9. And leave the negative 2y plus 3z equals to 5 alone. And now combine. Cancel the z's. 9y plus negative 2y is 7y. 9 plus 5 is 14. Good things are happening here. Divide by 7, divide by 7. This is going to give me 1/3 of my answers, the y equal to 2. On this step, I should be able to get both y and z from this set of equations. So I need to solve for z. I can pick that equation and put 2 in for y to solve for z. I can use this equation, plug 2 in for y to solve for z. It doesn't matter which. I'm going to use the bottom just because the z is positive. So as I go to solve for z, doesn't matter which one of these I use. I'm using minus 2y plus 3z equals to 5 along with y equal to 2. So I'm going to go negative 2 times 2 plus 3z equals to 5. That's going to give me negative 4 plus 3z equals to 5. I'm going to add 4 and add 4. That's going to give me 3z equals to 9. And then divide by 3, divide by 3. That's going to give me z equal to 3. That finally finishes step 3. Move on to step 4. Pick any of the equations for the last step that are from the original problem and plug in 2 for y and 3 for z. I think this equation is going to be nice. Even though it has some negatives, there's no number in front of the x. So for my very last step, I'm deciding on using the bottom equation. I'm going to use the equation to solve for x, because I have an answer for y, I have an answer for z. It doesn't matter which equation you pick. I picked this one because there's a 1 in front of the x, and maybe it's going to make my work easier. I didn't put the 1's in front of the x's and the z's, and maybe I should have. Let me try to see what I can do here. So for this equation, I'm going to plug in 2 for the y and 3 for the z in my efforts to solve for the x. This is going to give me x minus 6 plus 3 equals negative 2. I'm going to combine those together. That's going to give me x minus 3 equals negative 2. And then I'm going to add 3 to both sides. Plus 3 and plus 3. That's going to give me x equal to 1. I know now it's x equal to 1, y equal to 2, z equal to 3. When I write my answer, I write the numbers alphabetically, x then y then z, put them in parentheses and create an ordered triple. So x equal to 1, y equal to 2, z equal to 3. That's a funky looking 3 because I was about to write something different. And of course I could check. How do I check? I would go to the top equation, plug in 1 for x, 2 for y, and 3 for z. So let me do 2 times 1 for x plus 2 for y minus 5 times 3 for z. And I got negative 11, perfect. In the bottom equation, middle equation, minus and then 1 for x plus 2 for y plus 2 times 3 for z, and I get 7. And then the bottom equation, 1 minus 3 times 2 plus 3, and I get minus 2. So it works perfectly, just calculator checking. It only took a second to check. It's worth checking ahead of time. So last problem, and start any way you like. So there isn't always a right or a wrong way to start. And as I glanced at your problem, I would be tempted to either drop out the z's, pairing the top equation with the other two because the z's naturally drop out, or compare the bottom with the other two to drop out the x's. For mine, the only coefficient that's as negative as this top equation, what I'm going to do is I'm going to do the top with the other two, and drop out the x's. The x's, because they have opposite signs, make it a little bit easier. So I'm going to take the top equation, negative 1x plus 1y plus 2z equals to 1. Pair it with the middle equation of 2x plus 3y plus 1z equals negative 2. And the top equation of negative 1x plus 1y plus 2z equals to 1 with the bottom of 5x plus 4y plus 2z equals to 4. Just sit on this for a second. Make sure, the best you can make sure, that you haven't written down anything wrong. Make these negative signs stand out the best you can. Now I'm going to drop out the x's. For this pair, I'm going to make a negative 2 and a positive 2 for my x coefficients. Multiply the top by 2. Top will become negative 2x plus 2y plus 4z equals to 2. And I can leave the bottom equation 2x plus 3y plus 1z equals to negative 2. The x's cancel. 2y plus 3y is 5y. 4z plus 1z is 5z. 2 plus negative 2 is 0. This is one of those special times that I can divide and make my numbers easier. Each of the coefficients of the y and z, you can divide by 5 without getting a fraction, and you can divide 0 by 5 without getting a fraction. So rather than using the result that my algebra gave me, I'm going to use y plus z equals 0. when I get down to this next step. For this right pair, I'm going to multiply by 5 to make the x's cancel out. I'm going to go 5 times minus 1x is minus 5x. 5 times positive 1y, positive 5y. 5 times 2z, positive 10z. I just about wrote something down wrong. 5 times 1 is 5. Leave the bottom equation at 5x plus 4y plus 2z equals to 4. Let me make sure the best I can right now that I haven't made any mistake. Add these together. X's cancel. 5y and 4y is 9y. 10z and 2z is 12z. 5 plus 4 is 9. Again, if I notice that all the coefficients are divisible by the same number, really nice idea to do that division. So I'm going to divide everything here by 3 and get 3y plus 4z equals to 3. The smaller I keep my numbers, the more likely I am to do correct. That's the end of step 2. I picked the x and dropped it out. Now I'm going to move on to step 3. I'm going to take the equation that I'm going to write with the 1's, 1y plus 1z equals to 0. Stuff it on top of the equation, 3y plus 4z equals to 3, and just pray that I haven't made a mistake already, because if I have, everything I'm about to do now is a waste of time. I'm going to drop out the y's by multiplying the top by negative 3, and I'm having a hard time because I'm getting towards the bottom of my paper, so I'll work sideways. To multiply the top by negative 3, I'll go negative 3 times positive 1y and get negative 3y, negative 3 times positive 1z and get negative 3z, and negative 3 times 0 is 0. Underneath it, 3y plus 4z equals to 3. And now cancel out the y's. Negative 3z plus 4z is 1z. 0 plus 3 is 3. This gives me z equal to 3, which is great because I know that needs to be the answer. Now I need to get an answer for y. This top equation feels the best to use. This top equation is really just y plus z equals to 0. And I'm going to plug in 3. I'm going to go y plus 3 equals to 0. I could leave the 1's here. I could tell I didn't need the 1's in front of the z and the y, so I didn't put them because the math was going to be so easy that I didn't need them. So there's my y, there's my z. Last thing I need to do is get an x. And to get an x, you take any of the original equations, any of the top 3 equations, and plug in. I'm going to use the bottom one. There aren't any negatives in there. The negative in front of the x in the top equation might cause me to make a mistake. The negative over there might cause me to make a mistake. So let me use the bottom equation to get my answer for x. So I'm going to go take that equation, 5x plus 4y plus 2z equals to 4. I don't know what x is, but I'm allowed to plug negative 3 in for y and positive 3 in for z. Now I just need to solve this. So this is now going to be 5x minus 12 plus 6 equals to 4. I'm going to combine those and get 5x minus 6 equals to 4. Add 6 to both sides and get 5x equals 10. And then divide by 5, divide by 5, and get x equal to 2. Now I have all my answers. I'm going to write them in a nice order. Specifically, I'm going to write the x2 first, the y negative 3 second, the z positive 3 third. I'm going to call that my answer, and I'm going to check on my calculator the best I can. So best I can, plug in 2 for x, negative 3 for y, and 3 for z into each one of these. So the top equation, I'll do negative from the formula, 2 from z, plus negative 3 for y, plus 2 times 3 for z, and I got 1 like I needed to. Bottom, I'll go 2 times 2 for x, plus 3 times negative 3 for y, plus 3 for z, and I got negative 2 like I needed to. Notice I'm not using parentheses because they take longer to type. I'm just doing times signs. Bottom, 5 times 2 for x, plus 4 times negative 3 for y, plus 2 times 3 for z, and I got the 4. So I checked them in each of the 3 equations, so I know my answers are right, even though I thought my answer was going to be right anyways. So finally, the end is now here for section 6.1. We will not have such a long section for the rest of the chapter. The next few sections are shortish. 6.5 might be the only long section we have left.